In this class, now I would like to explain you nth root of a complex number. Let us assume a complex number z is equal to x plus iy. Convert this complex number into the polar form, or you can call it as modulus amplitude form. You know that. So while converting this complex number into the polar form, we get r cos theta plus I sin theta. You know, where r represents magnitude or modulus of this complex number, theta represents whose principal argument. You know, where theta belongs to close interval of minus pi radians to pi radian, or you can take theta belongs to open interval of minus pi to pi radians closed. You get one solution in one rotation. See, so from here to here, if you measure an angle in the anti-clockwise direction, it gives 0 to pi radians. So from here to here, 0 to minus pi. So here, this interval represents one complete rotation. Okay, students. So in this complete rotation, this gives one solution. To get that is called here principal solution, or you can call it as principal amplitude. Okay, students. So to get more number of solutions for this equation, you need to add 2k pi plus theta. This is called general amplitude of this complex number. This is called principal amplitude. If you write this expression, that gives us principal amplitude, where k belongs to an integer. You know 2k pi, which represents standard form of complete angle. If you write k equal to 1, you get one complete rotation. If you write k equal to 2, you get two rotations. Like that, if you keep on rotating, so you will get more number of solutions. Okay, students, what do you have to call this? General amplitude of this complex number. Okay, right. Now, see, for this I am going to find nth root. So here, what you have to write? Nth root of r cos theta plus I sin theta. So hereafter, r power 1 by n. So here cos theta plus I sin theta whole power 1 by n. In the next step, I am going to write this one as cis of 2k pi radians plus theta whole power 1 by n. Can I write? So here, you know, this can be written cis theta, but in the place of amplitude, I added 2k pi plus theta to get more than one solution, more than one root. We need to add 2k pi for this principal amplitude. You know, in the trigonometric equations chapter, there we use it to write first principal solution in its principal domain. To get more number of solutions, then we added general solutions formula. Same like that here also, to get more than one solution, you need to take this general amplitude 2k pi radius plus theta. So now apply the De Moivre theorem for this. If you apply the De Moivre theorem for this, then it will become, so nth root of z power 1 by n is equal to r power 1 by n. So cis of 2k pi plus theta by n, where k will take the values from 0, 1, 2, 3 till n minus 1. Okay, students, I hope you have understood. So this is the formula which we use to find nth root of this complex number. I explain you some applications based on this nth root of a complex number. Let us see those applications. See, I am giving you a problem. Fifth root of 1 plus root 3i. So how do you find 1 plus root 3i whole power 1 by 5? So take this 1 plus root 3i. Now convert this one into the polar form, modulus amplitude form. How you can find? R is theta. First find whose magnitude? Modulus. So root x square plus y square. X square value 1, root 3 whole square 3. So magnitude is 2. So write here R. Now cos theta. Theta is how much, students? Tan inverse of y by x. Okay. So tan inverse of y by x. Y value root 3 by x value 1. Now tan inverse of. Okay. You know this belongs to the first quadrant. 1 comma root 3 belongs to the first quadrant. So in the first quadrant, so where do you get root 3? Tan 60. So tan 60 degrees pi radius by 3, which becomes pi radius by 3 is the principal argument. Now write cos of pi radius by 3 plus I sin pi radius by 3. So this is the polar form of this complex number. For this, what you have to apply? Fifth root. So what do you do? Whole power 1 by 5 you have to take. Whole power 1 by 5. Now apply this exponent to this as well as this, so that you will get 2 power 1 by 5 inside cis of. Yeah, this is the principal domain. So I would like to add general argument 2k pi plus pi radius by 3 whole power 1 by 5. Now apply the De Moivre theorem for this. By that theorem, what do you get? 2 power 1 by 5 cis of, right, simplify this. Otherwise you can write like this, 2k pi radius plus pi radius by 3 whole by 5. If you go for still a simplification, you get 2 power 1 by 5 cis of, here 3 to the 6. So 6k plus 1. Okay students, 6k plus 1. So pi radius by 15 you will get here. 3 5 is a 15. Where k belongs to 0, 1, 2, 3, 4 till 4 values. 0 to 4. Total 5 roots we get for this. As you know, in the concept we learnt, k will take the values from 0, 1, 2, 3 till n minus 1. Here n value is 5. Last value 5 minus 1, 4 you will get. If you write k equal to 0, you get one solution. Like if you write k equal to 1, you get one more solution till 4 you have to assign for k. So that you will get 5 roots for this given complex number. Okay students? Right. Now let us see one more example. See. Now sixth root of 1 minus I. Same procedure. See here. Take this 1 minus I and convert into the polar form. Where does it belong? 1 minus I means 1 comma minus 1, which belongs to the fourth quadrant. If it is there in the fourth quadrant, you know, students. So whose principal argument is minus theta? Am I right? First find theta. So tan inverse of mod y by x. Because it belongs to the fourth quadrant, hence I have written modulus symbol. So here tan inverse of. So here minus 1 by 1. So mod is there. Minus 1 by 1. So minus 1 by 1, which becomes minus 1, but mod is there, so that you have to prefer only positive one. Hence tan inverse of tan 45. So what is the principal argument? Pi radius by 4. Okay students. Now magnitude is how much? Root x square plus y square, which is equal to root 2. Now root 2 times of, tell me, tan inverse of, root 2 times of cos of, tell me, pi radius by 4 plus I sin pi radius by 4. So you have converted into the polar form. Now apply the whole power 1 by 6, sixth root. If you apply that, what do you get, Amma? Students, tell me. So here 2 power, already 1 by 2 is there. If you take sixth root on both sides, this becomes whole cube. And what about this? Cis of 2k pi plus pi radius by 4 whole power 1 by 6. Now bring that 1 by 6 to the down, so that you will get 2 cube into, right? So cis of, so 8k plus 1 by, so here by pi radius by 24 you will get. Okay students, take the cross multiplication and bring this one to the down, so that you will get pi radius by 24, where k belongs to 0, 1, 2, 3, 4, 5. If you keep on substituting k value from 0 to 5, here you will get 6 solutions for this complex number. Okay students, I hope you have understood this. Now let us go to one more. See that like fourth root of minus root 3 minus I. Now what is our primary duty? We need to convert this complex number into the polar form. Observe this, which belongs to the third quadrant. So here in the third quadrant, first prepare the theta, tan inverse of. So what do you get, students? Mod of y by x, here y minus 1 x minus root 3 minus 1 by minus root 3. So minus cancel, you get tan inverse of tan pi radius by 6. Okay students, because tan 30 1 by root 3. So you got theta value, but this complex number belongs to the third quadrant. In the third quadrant, okay, that principal amplitude is minus pi plus theta. So here minus pi plus pi radius by 6, which becomes minus pi radius by 6 you will get. That is the principal amplitude of this complex number, because it is belonging to the third quadrant. In the third quadrant, this will be the principal argument. So here whose magnitude is, so you get 2 into cos of minus 5 pi radius by 6 plus I sin minus 5 pi radius by 6. Now apply the fourth root on both sides. Fourth root of minus root 3 minus I, which is equal to 2 power 1 by 4 you will get. So inside I am writing direct step, cis of 2k pi minus 5 pi radius by 6 whole power 1 by 4. That 4 will come to the down by the De Moivre theorem. Now let us simplify this. So after simplifying, this will become 2 power 1 by 4 here. Cis of 6, 2s are 12, 12 minus 5, so 7. So 7k minus 1 pi radius by 24 you will get, where k runs from 0, 1, 2, 3. Substitute k equal to 0 to 3, so that you will get 4 solutions. Okay students, right. Now the same manner, if the theta belongs to the second quadrant, in which you have to take the pi radius minus theta for the principal amplitude. So this you can try. I am giving you a complex number which belongs to the second quadrant. In the second quadrant, so x is negative, y is positive. Minus root 2 plus I. Try this. First find the theta with the help of tan inverse of mod y by x, and substitute the theta value over here, so that you will get whose argument, and follow the previous procedures, so that you will get Okay, so like here you can take 8th root of this minus root 2 plus I. Prepare theta and substitute the theta here, and so that you will get principal amplitude, and find whose magnitude and apply the previous formula so that you will get your required roots for this complex number. Otherwise shall I do? So get the theta value, tan inverse of y by x. Here y value 1, x value root 2. Tan inverse of 1 by root 2. So okay, here we are not getting standard angle, no. So you better to take as minus 1 plus I. Minus 1 plus I. Now prepare tan theta. Tan inverse of here y value 1, x value minus 1. So 1 by minus 1. Here use the modulus symbol so that you will get, so pi radius by 4. Now come back here and write whose magnitude root 2 whole power 1 by 8 and cis of 2k pi plus theta, pi radius by 4 whole by 8. Okay student, not theta. Here theta belongs to the second quadrant now. Hence here this is not our principal solution. So this is the principal solution. Pi minus pi by 4. So here 3 pi by 4 you have to write here. 3 pi by 4. Where k runs from 0, 1, 2 till 7. If you keep on substituting k value 0 to 7 here, you will get 7 solutions for that. Okay students, suppose if I give you a complex number like this. Okay students, see, let me explain you. Right, 32, fifth root of 32. What do you do? So here students, fifth root of 32. So you know 32 you would have to write 0 into I. So where does it belong? On the first quadrant. Sorry, on the positive x-axis. Where does it belong? See here, observe this. From in this portion it is there somewhere. So hence theta will be 0 degrees. So here what do you do? So 2 here, whose magnitude 32. 32 whole power 1 by 5. Cos 0 degrees plus I sin 0 degrees whole power 1 by 5. Now write the general amplitude. So this is going to become 2 power 5. 5 cancel. 2 of cis 2k pi plus 0 by 5. K will take the values from 0, 1 and so on till 4. Okay students, here no complex part in the given one. So in such case you would have to write like this. Okay, now where does it belong? On the positive portion of x-axis. So in such case theta will be 0 because there is no angle. Hence I took theta 0 and I substituted in the place of theta as 0 degrees. Okay, so here whole power, already 5 I have written. Now k will take the values from 0 to 4. Suppose if I give purely imaginary like this. See, 6th root of I. In such case what do you do? So 0 plus I you would have to write. Where does it belong? On the complex plane, on the positive portion of y-axis. Where does it belong? On the positive portion of y-axis. So here argument will be 0, 1. Pi radius by 2 you will get. So theta will be how much, Amma? Pi radius by 2. Now write. So here magnitude is 1 only. 1 power 1 by 6 becomes 1. So here cos of 90 plus I sin 90 whole power 1 by 6. Now apply the here cis form. Cis of 2k pi radians plus principal argument pi by 2 whole power 1 by 6. Now if you apply De Moivre theorem for that, you get 2k pi plus pi by 2 by 6, where k will take the values from 0, 1, 2 till 5. Okay students, no confusion here. There is no real part. Hence, I have written 0 plus I, which belongs to the positive y-axis. If a point is there on the positive y-axis, whose argument will be pi by 2, 90 degrees. So in such case, you have to find whose roots like this. So sometimes they may give you like this. So cube root of minus 8 or otherwise minus I. So now in this case also, in the real part you have to take 0. So now where does it belong? Here you better to take like this. Minus 1. Cube root of minus 1. So here there is no imaginary part. So here minus 1 plus 0I. So here where it is on the argand plane, negative portion of x-axis. See here, somewhere you will get here. This is x-axis, this is y-axis. It is real axis, it is imaginary axis, you know. So how much is the argument? Pi radians. So what do you write? This minus 1 plus 0I can be written as, so cos pi radians plus I sin pi radians. Cos pi radians minus 1, sin pi radians 0. Again you will get this. Now apply the cube root for this. Cube root. So magnitude is 1. No need to write that magnitude. So here cis of 2k pi radians plus pi radians. So by 3 you will get. Take pi by 3 outside. Cis of 2k pi plus 1 pi radians by 3, where k will take the values from 0, 1, so 2. If you keep on substituting 0, 1, 2, here you will get 3 solutions for this given complex number. I hope you have understood. So like this, you people have to find nth root of a complex number. Thank you students. Thank you one and all.